Hi everyone, in this session we are going to see the topic how a parallel system differ from a distributed system. Introduction. To understand the key difference between parallel systems and distributed system. Essential for computer science, engineering and IT professionals. So what is parallel systems? A parallel system consists of multiple processes working together on a common task, usually sharing memory and often located within the same physical machine. The features of parallel systems are: processes access a common address space. Processes are closely connected, often sharing hardware resources. Equal latency to access memory from any processor. Multi-core CPUs and supercomputers and array processors. In this diagram, we can see the parallel file system architecture with a single node and the individual input and I/O linked to the storage array. So, data containers is taken and stripped across the multiple devices. So, the next subtopic is what is distributed system? A distributed system is a collection of independent computers or nodes that appears to use a single coherent system connected by a network. Some of the features related to distributed systems are: no shared memory. Each node has its own memory and operates independently. Loosely coupled. Nodes are autonomous and may be geographically separated, which means the distributed computers will not be at the same location. Communication via messages. Nodes interact by passing messages over a network by pinging method. Example: cloud computing, web services, and peer-to-peer networks and distributed databases. In this distributed file system architecture, we can see the network linked to the storage arrays and the data is secured among the different locations. So these are the key difference between the parallel system and distributed systems. So first one is memory. Shared memory among the processes. No shared memory, each node is separate. Coupling. Tightly coupled, and in distributed system it's loosely coupled. Location. In parallel systems, same physical machines or closed machines. In distributed system can geographically depressed. In communication, the parallel system have shared memory or high speed bus. In distributed system, message passes over a network. Synchronization. In parallel system, easier, often hardware unsupported. In distributed, more challenging needs and protocol supplements. Failure handling. Single point of failure is possible in parallel systems. More fault tolerant can and replicate nodes can be used in distributed systems. Scalability. In parallel system, limited by hardware and constraints. In distributed system, it's highly scalable across many locations. These are some use cases of parallel systems: scientific computing, real-time data processing, graphical rendering, and machine learning. In scientific computing, used for simulations, modeling, and data analysis that requires high-speed computation such as weather forecasting and molecular modeling. Real-time data processing is essential in applications like video processing, signal processing, and robotics, where the tasks must be completed within a strict time constraints. Graphic rendering. Power 3D rendering in video games and movies utilizing GPUs with thousands of parallel cores. Machine learning. Training large language neural networks effectively by distributing computations across the multiple cores. Use cases of distributed systems, cloud services, banking systems, internet applications, and distributed database. Cloud services, backbone of platform like Google Cloud, Amazon Web Services, and Microsoft Azure, enabling scalable and reliable computing resources. Banking systems ensure high availability and fault tolerance for transaction and account management across geographically depressed branches. Internet application supports web services, social network, and e-commerce platforms by distributing workloads across the multiple servers. Distributed database used in systems like Cassandra and MongoDB to provide data redundancy, scalability, and fault tolerance. So, we came to summary of parallel systems and distributed systems. Parallel systems are about multiple processes working closely together, sharing memory, typically in one physical location. Distributed systems are about independent computers collaborating over a network, each with its own resources. Choosing between them depends on a problem requirements, speed and tight coordination, or parallel, or scalability and fault tolerance. Distributed.